So without getting into any of the nitty gritty, we're going to stay away from all the mathematics. Today, we're looking at how we can start to look at a substance, look at some matter, and make some observations. How can we start to describe the things we are seeing in the laboratory setting? And so there's kind of three different ways we can start to observe or look at our matter in our lab. The first is just based upon its chemical or physical properties or chemical and physical observations. We can also think about our chemical versus physical changes. Now the big difference, the big takeaway is if you have a chemical property or a chemical change, we're looking for something new or how it could potentially change into something new in terms of our substance and its atomic arrangement. Now this does need the breaking and forming of chemical bonds. And we're going to spend a lot of time talking about this over the course of the year. A physical observation or physical change does not alter the arrangement of the atoms in the substance. It does not result in a new substance. Now there's a couple of things that we can kind of use to give us a hint or to imply, let us kind of observe or deduce that perhaps something new has been created, that we've had a chemical change. First thing we could look for is the creation of a gas. If all of a sudden you mix two things together and bubbles start coming out, pretty good chance that we've got a chemical change taking place. Another thing we can look for is a change, and I'm going to underline that, a change in color. Now specifically, we need a new color to be present. If we take two colorless liquids, we pour them together and we have a new color presented, well, probably something has now formed, a new chemical or compound has formed that was not there before. Our third thing we can look for is the creation of an odor. This often kind of goes hand in hand with our kind of creation of a gas, that we have a new smell that wasn't present. Well, our particles must be rearranging to create something new for us. Fourth thing we can look for is a change in energy. Change in energy. We've mixed two things together, all of a sudden it gets hot, or all of a sudden it gets cold. We didn't change the temperature directly, we didn't put it on a hot plate, and now all of a sudden it's boiling. Hopefully you know that the steam coming off is still water vapor. That is a physical change. That state change is occurring because we are physically adding heat to the system. Here we're talking a change in energy that is spontaneous or happens on its own. We add two things together and all of a sudden it gets warm. It's exothermic. Exothermic, a release of heat energy. Or if you think about like the cold packs, we got this enclosed system. We kind of smack the metal and we break the two parts, or we break the seal and the two parts start to mix. And all of a sudden it gets really, really cold. It's absorbing heat energy. We would say that that is an endothermic substance. So exothermic, exiting, endothermic, absorbing, change in energy on its own. Sometimes this could be light. All of a sudden it releases light energy. That would also be an exergonic, releasing energy. In this case, it would be in the form of light instead of heat, but I digress. Fifth thing we can kind of think about or try to see if we have a chemical reaction is the production of a precipitate. I probably spelled that wrong. Precipitate. I think it's an I. Sorry. Formation of a precipitate. A precipitate is a solid. Again, we're not freezing. We're taking two liquids, we're mixing them together, and all of a sudden it becomes kind of a cloudy or opaque. We can no longer see through it. It means there are particles that are forming that are large enough to block our ocular vision. And so these are five things that can kind of clue us in or key us in that maybe we've got a chemical change taking place. Now we could also just think of these terms of their properties. If I tell you that a piece of paper is flammable, I'm not actually changing it, it's not technically a change, but it is still describing how it could change. Flammability is a chemical property. If we say the paper is white, well, that's a physical property. I'm just describing the physical substance and how it appears to me. So big piece when we start to look at our labs in particular, did we have a chemical change? Did we not have a chemical change? These are things we can be looking for to key us in on whether or not we've had a change. Another way we can start to classify our observations and I think a lot of us have heard of this before, is quantitative versus qualitative. I love science words because they just give you those little hints. They kind of clue you in. Quant versus qual. A quantitative observation is an observation that relies on numerical values. You had to measure something to get a quantitative number. So quantitative, we're looking at a number. So for example, if I said that this room is 2.5 meters in height, that would be a quantitative observation. I've measured and I've got some values. A qualitative observation is just based on your general senses. You're not measuring anything with a tool. We're just kind of describing what we see as its outward appearance. So a qualitative observation, for example, if I said the soda pop is cold, that would be a qualitative observation. I could make it quantitative. I could stick a thermometer in there and say, oh, it's 15 degrees Celsius. Now I've got a quantitative observation. But because I didn't use a tool, and I just said it was cold, that's a qualitative observation as we start to describe our matter using kind of our outward senses. Our last two here, which are probably going to be new for us, I don't think we cover these in Chem 1 anymore. We've got intensive versus extensive. Intensive properties are properties that are independent of the sample size. Extensive properties are dependent on the sample size. And so when we think about our different substances, different things that we can measure and interact with, some of them, it doesn't matter how much of that substance you have. It's an intensive property. So for example, if I say paper burns, it doesn't matter how much paper I have. Well, going back to flammability, oh, that's a chemical property, or talking about how it could change chemical property, but it's also an intensive property. It does not matter how much paper I have, it will all burn. An extensive property does depend on your sample size. For example, mass. If I said I have 20 grams of sodium bicarbonate, well, that mass is specific to those 20 grams. If I had a larger sample size, its mass would be a larger value, would no longer be the same. Another good example here is when we start to think about, for example, volumes. If I've got 50 mils of water, well, that's different than if I had 100 mils of water. It's specific to that sample. One that we really like to think about and talk about when we think about intensive and extensive is density. Density, we've got how compact or how close our particles are to one another. Density is an intensive property. If I have a styrofoam cooler and I throw it out on the lake, it still floats. It is less dense than the water. If I have just the cooler lid and I throw that on the lake, it still floats. The degree of packedness does not change. Even if I take the cooler lid and I break it in half over my knee and I throw the parts back on the water, well, they still float because it is independent of the sample size. Now, the good news is, and we'll talk about this more in depth, that yes, if we're looking at density, the mass changed, but so too did the volume, and as a result, the particles still have the same degree of packedness. That's an intensive property. So let's take a minute, let's look at some examples, show you a couple examples that we can start to be thinking about, and then we can kind of think about how we observe our different substances. So let's look at a couple examples of our chemical versus physical changes, our quantitative and qualitative, and our intensive and extensive. Now, oftentimes, we can classify these as multiple categories. So for example, here I've got a test tube. Sorry for viewing purposes, I'm trying to give you guys a good shot here. Got a test tube. We've got an unknown substance on here. It is sodium bicarbonate. That's what we've got down here in the bottom of our test tube. You could give me some pretty straightforward qualitative and physical properties. If I was to describe the color, well, it's white. That's a physical property. It's solid, also a physical property. I've got, solid. That's also a qualitative property. I didn't measure the degree of hardness. I don't have any values in there. That's also a qualitative property. It is also an intensive property. If I say this solid, if I were to cut this sample in half, it would still be a solid. And so we can start to think about all the different ways we can describe our substances. And now we're going to look to see if we can create a change. I've got another substance here. Let me get it in frame. I've got approximately 10 mils of acetic acid. It's a liquid. It is colorless or transparent. We've got 10 mils. Ooh, 10 mils. That would be quantitative in nature. It's also extensive. It's specific to the 10 mils in our graduated cylinder. If we take these two and put them together, we can see if they start to change. I put too much. If we look, we've got the production of a gas. We've got a considerable amount of gas coming off, which is one of our 5 indicators of a chemical change. We've had a chemical reaction here. For those of you that are familiar with your chemical compounds, you know that this was the classic baking soda and vinegar demonstration. I know, classy stuff as we start off our year together. Another example for us, if we think about our lowly sugar cube. Here we've got a cube of sugar. If I were to think about how I could start to describe it, again, I've got a solid at room temperature. We've got a cube. I could find its mass. If I said it was exactly 5 grams, that would be 5 grams would be an extensive property. It would also be a quantitative property for our sugar cube in question. I could go ahead and actually take a substance and I could cut it in half, right? Not quite half, but we've altered its outward appearance, but it is still sugar. That would have been a physical change of our sugar cube. I could theoretically light it on fire. I'm not going to, it's pretty stinky. If I were to light it and fire would change to something new, that would be a chemical change, and we would see some signs of that. Here we've got some more substances we can start to look at. I've got some potassium carbonate and some calcium nitrate. If we're thinking about our solubility rules, we might be able to predict what our reaction is here if we were to write this out, but we're just kind of looking for some signs of chemical and physical changes. We've got 2 colorless substances, 2 colorless liquids. I'm going to go ahead and put them into the same spot plate here. Promise we'll get you a closer look here in just a second. Boop, 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 boop. It is no longer transparent. We have created a precipitate. We also had a color change. We went from transparent to a white cloud. A couple more for you. We've got some silver nitrate. Kind of this, it is a colorless substance. We've got some contamination on the bottle. It's giving it this grayish color. We've got potassium chromate, which is this kind of lovely amber yellowish color. Here, let me get that in the dish for you to see. So here is, right there in the middle so you can get the contrast. There's our potassium dichromate. Excuse me, I misspoke. And then here's our silver nitrate. Coming on in. We end up with this lovely kind of blood red color. It is also a precipitate. We can no longer see through it. So just some examples. That would be a chemical change. We saw a color change. We saw a precipitate form. We got a couple different examples of both chemical changes taking place here. We've got physical with our sugar cube. We also have chemical with our bubbling sodium bicarbonate flask. Ooh, we talk limiting in excess, but that's for a future video. Great.